We're going to look at the calculation of a p-value and the conclusion that we'd make from a hypothesis test using the normal curve as our model instead of a simulation. We'll still use the StatKey website to do our calculation, but we're going to use a different model or approach on how to calculate. So this statement says, John claims that 42% of aliens are friendly. Given a long history of watching movies, you think the true population proportion is far less. Using an SRS of the universe, sending a friendly robot to each member of the sample, you find 33 friendly aliens and 92 unfriendly ones. I would imagine that with each robot that was sent, either they responded well to them or didn't, and so that's where you get your yes or no that makes up your proportion. So let's go ahead and create all the pieces of our hypothesis test so we know how to work this. It's going to start out the same as we do with the simulation. So our null hypothesis, we need to choose a symbol. It's always going to be mu for means or p for proportions. So we have a proportion, and so we will choose that. And it's always going to be equal to the claim. And in this case, that is 42% or 0.42. The alternative hypothesis is always going to be the same thing, p and 0.42, and we have to now choose a direction. Not equals for it could be either way, and then less than or greater than. You think it is less, so the alternative is less than 0.42. We need to choose a reasonable alpha value, and for this we could choose 0.05. Now, before we go on to actually calculating, the normal curve assumes a few things, and so we're going to have to state some assumptions. And so I am going to list 3 things that we always want to check for when we're dealing with a normal curve. The first one is that our data is random, that we have an SRS. That's going to actually be true with StatKey as well, because anytime you have ineffective junk data, it's going to cause a problem with your results. So we always are going to need, no matter what our method, an SRS. Next one is we want to check for independence. And what that means is that our sample is not a huge percentage of the population. So if our population only had 500 people and we took a sample of 100, we would have 20% of the population. We want to keep that less than 10%. So sample should be less than 10% of the population. And if we look at this problem, it looks like we've got a handful of aliens, a little over 100. I think it's fair to assume that there's over 1,000 aliens in the universe if we're working on this. If they're able to run a simple random sample and obtain that many, I think that it's a reasonable assumption. And then finally, the last one we always check is for a normal shaped graph. If we had means, we would actually look at a sketch of a dot plot or a histogram. But since we're dealing with proportions, the way we check for normality is having at least 10 yeses and at least 10 nos, at least 10 successes and 10 failures. And so you see here that we have 33 friendly, so 33 yeses, and 92 unfriendly, so 92 nos. So 10 plus success, 10 plus fail, and all 3 of these conditions we believe are met. So now, only after going through those assumptions can we move on to an actual calculation. We're going to use a normal curve. And so the normal curve generally always looks in this basic shape. And the center of a standard normal curve would be at 0, and then a tick mark on the number line, a standard deviation occurs somewhere around here. And then it goes and continues to count by that all the way down forever and ever. And so you can see that most of the data is within 2 standard deviations. About 95% of the data is within 2 standard deviations. And so if you're looking to obtain a small p-value in the tails, you would be looking to get out roughly that far, at least a couple standard deviations. Now, the nice thing about using StatKey for our normal distribution to draw it is that it'll relabel this axis not 0 and 1 and -1, but it will actually relabel that axis with the actual data we have. So it might say 0.42 in the middle, since that was our null hypothesis. And then the amount over that it counts will be dependent on how wide of a distribution we would expect from this data, how much variation is typical. And there's a formula for that. And so that's what that standard error formula was right here. This p times 1 minus p all over n, the whole thing under the square root. So let's try that formula out. It's not as bad as it looks. We are going to take the square root of p, and p is our null hypothesis right there, our claim. So 0.42. We're going to multiply that by 1 minus that. And so you could literally write that out, or in my case, I would just prefer to write the probability of not success, which is predicted to be 0.58 by the claim. And we're going to divide that by our sample size. And in this problem, we aren't actually given sample size. We're going to have to add that up ourselves. So 92 plus 33, it's going to be 125. That is our sample size. So we'll divide that by 125. And if we take these numbers and we put them in our calculator, we will get 0.0441 approximately. So we will write that in. What that's going to do is help us draw the curve. When I was giving the example earlier of how far over we would go on that curve, we're going over about 0.04. So the next one would be around 0.46, a little bit higher. And the next tick mark here is going to be around 0.51 if we round that up, and so forth. And on the other end, it's going to go down about 0.04 or 0.05. And so we're going to see this number line on the bottom of our graph in StatKey follow that. So let's go ahead and jump to that. If you go to StatKey, near the bottom, you're going to see theoretical distributions, and you're going to see the normal curve. So let's go ahead and click on the normal curve. And there it draws the curve right in front of you. So we need to edit the parameters. The mean is the middle, and that's always going to be our claim. So that's 0.42 in this problem. And the standard deviation, that's our standard error of the sampling distribution, which is that formula that looks at successes, fails, and sample size. So in this case, we got 0.0441. And you could go more decimal places if you're into that kind of thing. And if you look at our number line here, we have the middle lines up roughly with 0.42. And you can see that by the time you get to this inflection point here, you're around 0.46, 0.47. And that would be our first standard deviation, and it continues to count by this number here. Now, that's all fine and dandy, but we want to actually calculate the p-value. That's our whole goal. So if we go back to where we had our p-value, we are going to need to compare it to our p-hat, our sample. And in our sample, we had 33 friendlies out of 125. So if we go to our alternative hypothesis, we said less than left tail. So let's turn on the left tail. And we're going to need to edit this cutoff value. Now, 33 divided by 125 is something Google can calculate for us, 0.264. So this is my p hat. Just like in StatKey on the simulations, where you would use the p hat, the sample proportion or sample count from this box up here, we are going to use p hat from our original problem to set the cutoff, to set the slider. And when we do that, we get a number that's floating up here. That number tells us our p-value. And so in this case, we have an incredibly small p-value, so small that we can't even really see the shaded red region. And the number here is tiny, 0.0002. So let's record that. Our p-value is 0.0002. That is really little. So our conclusion in context, are we going to reject or fail to reject? When p is low, in particular, when p is lower than our alpha value, we absolutely will reject. And in this case, it means that if John's claim that the 42% of aliens are truly friendly, there is a 0.0002 probability or a 0.02% chance of finding results as low as I did. That means that we have a very, very low chance of finding our 33 out of 125 if this claim is true. Therefore, we reject the claim.